right, let's take a look at the quiz yourself questions for section 12.2. Assume that you are shopping for a new car. There are 2 different models to choose from. There are 8 different colors available. Each model has 3 different interior packages, and each model comes with either a plain or sports trim package. How many different cars do you have to choose from? Let's use the fundamental counting principle and the slot diagrams to help us see the answer. First, we'll need to choose from the models. There are 2 different ways to choose which model we want to look at. Next, we'll choose the color. There are 8 different colors to choose from. Each model has a different interior package. With 3 choices, and each model comes with an exterior package of plain or sport. Now let's reread the list and make sure we've got everything. There are 2 different models to choose from. There are 8 different colors available. Each model has 3 different interior packages, and each model comes with the plain or sports trim package. All right, so it's always good to double check. Now, if you forget whether you multiply or add right now, you can always imagine a tree, right? If you imagine that there's 2 possible outcomes in terms of the model and 8 colors, you can quickly remind yourself that now we have 16 choices, not 10, right? So we multiply. Two times 8 times 3 times 2. 2 ways to pick the model, 8 ways to pick the color, 3 ways to pick the interior package, and 2 ways to pick the exterior package yields to 96 possible car choices. Not bad. In Quiz Yourself 6, they've asked us to review example 6, but now assume that the class has 12 students and the first row has 8 seats. This is the example of Louise and her tutor. In Professor Bartlett's class, Professor Bartlett teaches an advanced cognitive psychology class of 10 students. She has a visually challenged student, Louise, who must sit in the front row next to her tutor, who is also a member of the class. If there are 6 chairs in the first row of her classroom, how many different ways can Professor Bartlett assign students to sit in the first row? All right, now again, looking at example 6, they split it into 3 tasks. Task 1, decide which 2 seats Louise and her tutor will occupy. Task 2, decide where Louise and her tutor will sit in these 2 seats. And task 3, determine who will sit in the remaining seats. All right. In our example, we have that there are 8 chairs. So let's imagine our 8 chairs. 1, 2, 3, 4, 5, 6, 7, 8 chairs, right? And we still know that Louise and her tutor need to sit together, right? So Louise and her tutor, they could sit here, for example. They could sit together in seat 2 and 3. They could sit together in seats 1 and 2, 2 and 3, 3 and 4, 4 and 5, 5 and 6, 6 and 7, or seats 7 and 8. So there are a total of 1, 2, 3, 4, 5, 6, 7 ways to seat Louise and her tutor across the front row. But in each one of those spots, maybe we sat the tutor and then Louise. So in each place that we decide they can sit, it's one of two choices. Either Louise sits down and then the tutor, or the tutor sits down and then Louise. So in each spot, there's two, oops, I erased it. There's two possibilities for the way that they sit. Giving us two ways to seat them in the actual location that they've chosen. Now, let's imagine they've sat somewhere in the middle, taking up these two chairs. What are we left with? Well, we're down to 10 students and we are down to 6 chairs, 3 on one side, 3 on the other. Any of the 10 remaining students can sit in the first chair. Once they sit down, we only have 9 students left to seat. They sit down, right? Now we only have 8 students left to choose from. The number of ways to pick, oh, the number of ways to pick someone to sit in the last few chairs. We only have 7 students left to choose from. Someone sits down. We only have 6 students left to choose from. So someone sits down. We only have 5 students left to choose from. So the number of ways to select 6 students to sit down out of 10 is 10 times 9 times 8 times 7 times 6 times 5. 6 chairs, 10 students. And now, using our fundamental counting principle, there were 7 ways to do task 1, there were 2 ways to do task 2, and there were 10 times 9 times 8 times 7 times 6 times 5 ways to do task 3. Now, when we put this in the calculator, 7 times 2 times 10 times 9 times 8 times 7 times 6 times 5. Make sure you stop yourself. We have 2,116,800 ways excuse me, to seat the front row in this class.